Okay, we're going to deal with something real in calculus. The first thing we want to learn is limit. Okay. Limit, that means it's something approach to a number when x or y, a variable, comes to a number, gets very, 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 very close. What does that mean? For example, y equals x squared. Okay, this is a function, or f of x equals x squared. It's a function we know. And if you graph it, it looks like this. There's 1, 1, 0, x, y, right? Okay. 1, 2, that's 4. There's 1, so there's 2, 4, so negative 1, 1, negative 2, 4. So you get 5 points. You get 5 points. You can connect them. You get the graph. That's what you'll learn. You should be really good at this after you learn the precalculus. This is a graph. F of x equals x squared. Now, when x approaches to 2, when x goes, if you go from the left to 2, very, very close to 2. Or from this side to 2, very, very close to 2. See, your graph of this function gets really, really close to this point, and the function value gets really close to 4 from the lower side, and also this way approach to 4 from the upper side. So that is the very, very easy limit you can find out. Okay, there is a notation you're going to learn is limit as x approaches to 2 x squared, that limit is 4. Okay, so this is a very interesting notation that you have never learned before, and that's the first time you see it. Okay, now I give you another function as an example. F of x equals x squared when x is not 2, and it's 0 when x equals 2. Now, if this is the case, the graph will look like this. Okay, so this is 0, 1, 2, 0, 1, 2, 3, 4, that's y, and here's negative 1, okay, negative 2, and then you still have this point, this point, this point, and when x equals 2, y equals 0. So you have this. That's your solid point here. And then here you have 4. For this moment, for this point, when x equals 2, the definition is this. When x equals 2, it's 0. But when x is not 2, it's x squared. So your graph look like this. It's a piecewise function. Okay, is that interesting? Now, what is the limit when x approaches to 2? What's the limit of this function when x approaches to 2? When x approaches to 2 from the left side, from the right side, no matter which side, that y approaches to 4. So it's still 4, even f of x equals 0 when x equals 2. Okay, even this happened, we still have the limit. Now this way, this two way I look at this, I graph the function, so it's called, I found this approach graphically, okay, because use the graph. And also you can use numerically, that means you just plug in the x equals 2 here, so you get a 2 squared, which is a 4. So that's another way. Okay, and there's another method called a numerical method. What does that mean is this. When x approaches to 2, what you need to do is you come up with a little table instead of graphing it. Okay, f of x equals, let's say x squared. So here's x and here's f of x. All right. Now I want x approach to 2. So it's an invisible 2 here. Okay? Even you don't see that, I don't ask you to do that. So you can go a little bit above and below 2. For example, you go from 1.9 and here's 2.1. And then you're going to find out what is f of x, which is 1.9 square, right? Here's 2.1 square. And then it gets closer, you go 1.99, closer, right? When I say approach to 2, okay, then 1.999, and this side from 2.1, we go 2.01, 2.001, and of course you can get even more, right? You can get a 1.99999, you can get a 2.000001, and then, okay, you're going to use a calculator. So I just use my calculator, you can use yours. So you go 1.9 square, I get a 3.61, all right? 1.99 square, I got a 3.9601, okay, and a 1.999 square, I got a 3.996001. It's very close to something. And here, 2.1 square is a 4.41, right? 2.01 square, I get a 4.0401, and then next 2.001, 4.004001. Now if you look at the numbers, if you look at those numbers, when x approaches to 2, when x approaches to 2 from the left side, from the right side gets closer and closer, closer and closer, and your f of x gets closer and closer and closer and closer to 4. So this is called find this limit using numerical approach. All right, I think in the homework you have some exercise about that. You can just try it and to see. And I bet no one really want to do that. No one want to do this, use this way to find the limit. And be careful about this point here. When x equals 2, we don't have to. We just say approach to 2. We don't touch it. So that means you don't need to worry about that. You don't need to calculate. And if you have the function like a piecewise, then this point at the, when x equals to 2, your f of x or the function value might be different than the limit. Okay, sounds good. So those are the three. Those are the methods that we learn how to do it. Another example. F of x equals x squared minus 4 over x minus 2. X squared minus 4 over x minus 2. Now in this case, x cannot be 2. X can, or the domain in the range, right? The domain is all real number except 2. X can be any real number except 2. Now if you graph it, if you graph that, you choose some x value and you get the f of x, okay? And then you get a certain point and you graph it. Guess what? If you simplify this a little bit, because we know this x minus 4 is x plus 2 times x minus 2. If you don't know how to do this factoring, you might want to review a little bit, okay? And then divided by x minus 2. And in this case, because x is not 2, so x minus 2 is not 0, and I can cross it out, I got x plus 2. Still, I still have this in my mind, x cannot be 2. So f of x is x plus 2. I know it's a straight line. It's this. Okay, so that's y. Here's 1, 0, 1, 2. This is f of x equals x plus 2, but x cannot be 2, which means that there is a circle here. Circle means get rid of this point. So that's your graph. That's your graph. You get a straight line, but you get a broken straight line. Alright, now if I ask you to find the limit as x approaches to 2, f of x, the answer is 4. Alright, so that is the 3 easy beginning part of the limit.